अच्छा जी, स्क्रीन नजर आ रही है आपको?
जी सर, आ रही है।
ओके, अच्छा, आज जो हम लोगों ने टॉपिक डिस्कशन करनी है, दैट इज थर्मल प्रॉपर्टीज ऑफ मैटर. ओके, सो व्हेन वी टॉक अबाउट थर्मल प्रॉपर्टीज ऑफ मैटर, इट मींस वी हैव टू टॉक अबाउट स्पेसिफिक हीट कैपेसिटी, वी हैव टू टॉक अबाउट boiling point, melting point, means state change. Okay, and then we have to talk about thermal expansion and all that stuff, right? So first of all, when we talk about specific heat capacity, it means that we are talking about the substance when it is heated. Let's say मेरे पास कोई भी substance है, when I'm going to change its temperature from one point to another point or from one value to another value, I need some heat. So when we provide some heat to a substance, Q is the heat. यहाँ पे हम लोग mention कर लेते हैं कि Q is heat supplied to the system. Okay, and then m is the mass of that system. अगर हमारे पास ये सारे parameters हों, तो delta theta is change in temperature, right? What is delta theta? Change in temperature. Then what will happen to us? Then we will say that this Q is directly proportional to mass. I mean, requirement of the heat is directly proportional to mass of the substance. Requirement of Q is directly proportional to change in temperature of the substance. ठीक है. अगर आप ज़्यादा मैस है तो उसका टेम्परेचर बढ़ाने के लिए आपको ज़्यादा हीट चाहिए होगी. अगर आप टेम्परेचर ज़्यादा बढ़ाना चाह रहे हो तो यू नीड मोर हीट. So simply speaking, delta Q is directly proportional to m delta theta. So when I replace this proportionality sign, I get a constant over here that is equals to m delta theta, and that constant is called specific heat capacity. What is the name of that constant? That constant is your specific heat capacity. So if I say that delta Q is equals to C m delta theta, which is a renowned equation as Q is equals to mc delta theta. We will call this Q is equals to mc delta theta.
सर ये एम डेल्टा टी नहीं
डेल्टा
होता?
टी नहीं होता आपके सिलेबस में, इसको हम लोग डेल्टा थीटा कहते हैं. डेल्टा टी इज थर्मोडायनामिकल टेम्परेचर. वो
अच्छा
आप
सर,
लोग
हम तो
ए
इसको
लेवल्स में आओगे तो
डेल्टा
देन वी विल. Actually, जो टेम्परेचर है ना, टेम्परेचर, व्हेन टेम्परेचर इज मेंशन इन डिग्री सेल्सियस, right? So the at that time we represent it with theta. But when we consider the same temperature in Kelvin, right? So we write it T in Kelvin. Okay. तो ये बेसिकली ये लेवल्स में आगे इसको आप T कह दोगे, बट हियर इट इज जस्ट थीटा.
तो
ठीक
सर
है.
अगर
इज
इस
इट क्लियर?
जगह हम टी कर भी दें तो इज इट अ बिग डील?
तो नहीं, ठीक है. सो Q कैन बी इक्वल्स टू m c delta T. You can use this one as well. I mean, no problem at all. Okay.
ठीक है सर,
So this is
ठीक
the
है।
master equation in your specific heat capacity. So I was talking about that. Here, what is this C? C is actually this specific heat capacity, this one, what I have written at the top. So when we talk about this specific heat capacity, it means that this specific heat capacity is the property of the substance. So when we so it would become Q divided by m delta theta.
सर व्हाट इज क्यू एक्चुअली?
Q is the heat. I have stated at the start. Q is the heat, right? Whatever you are going to provide thermal energy. आगे चल के हम इसको internal energy का नाम भी देंगे. It is your thermal energy, right? So
यस।
Q is that amount of heat which is being supplied to the system. Here I have explained this in detail. That internal energy of the system is that heat. So let me just write down this equation, that C is equals to Q divided by m delta theta, or you can say Q divided by m delta T. So when I consider this, what is the unit of this C? Unit of C is joule per kg per degree centigrade. Okay, or simply you can say joule kg minus 1 centigrade minus 1. So this is actually the unit of your specific heat capacity. So is it clear to you?
यस सर।
Right? Okay. So here is that. Yes, yeah, yes. Assalamu alaikum. Yeah, yeah. How are you?
Assalamualaikum, sir.
Yes, walaikum salam. Are you back?
Yes, I am.
Okay. Okay, so today we are at this topic. I was discussing with Miriam, so I'm going to give you a quick review so that you can join with us. We are talking about the thermal properties of the matter, and thermal properties consist of specific heat capacity, state change, right? And then thermal expansion and all that stuff. So first, first topic is specific heat capacity. So when we talk about specific heat capacity, it is actually it has an origin of this specific capacity, and that origin is if I apply or if I supply some heat to a system Q, if the mass of the system is m and its temperature changes from theta 1 to theta 2 or T1 to T2, delta theta is the change in temperature, or you can say delta T is the change in temperature, then the heat which is being supplied to the system is directly proportional to mass, is directly proportional to change in temperature. So when we remove this proportionality constant, we apply a constant over here, and that constant is C. So it is now Q is equals to mc delta theta. So this C is your specific heat capacity, what I was talking about right now, that we have to discuss about this C, and this C is specific heat capacity, right? And then I just rearrange this equation is rearranged in this way, that C is equals to Q divided by m delta 3 or the m delta theta, where Q is measured into joule because that is thermal energy, mass is kg, and C is degree centigrade, so it is temperature. So it has two units, joule per sorry, it has one unit that can be written in two formats. One is joule divided by kg into centigrade, or second one is joule per kg per degree centigrade. So these are the units you have to remember. Okay, is it clear?
Yes,
Okay, now I was talking about thermal energy, internal energy. Internal energy is basically that energy which is being supplied to a system, and it becomes part of that molecules, or it becomes part of that system. For example, you know, in a body there are molecules, or we studied about kinetic molecular model, that there are some particles in all type of substances, right? If they are solid, they vibrate, right? These particles vibrate. If there are gases or liquids, these particles vibrate, as well as they move or they translate. So what happens when they vibrate? They have just, oh sorry, they just have is that screen still shared?
yes,
Yes, sir.
Okay, okay. So they just vibrate. So when they vibrate, they have potential energy. And when they move, they have kinetic energy. So remember this thing, that internal energy is the combination of total kinetic energy due to motion, I mean translated in motion, and potential energy due to intermolecular forces or vibration of the particles in a body. So what is internal energy actually? Total thermal energy of the system, thermal energy or internal energy, because you are asked what is internal energy, right? It is named as internal energy. So the internal energy is sum of kinetic energy and potential energy of the molecules. What is that? It is sum of kinetic molecular energy, molecular kinetic energy and molecular potential energy. So I can simply write that it is is sum of molecular kinetic energy and molecular potential energy. वो ले लो. And molecular potential energy. Okay, वो ले लो. Okay, therefore, as a temperature rise, now this is what, when the heat is given to a system, the atoms and molecules of they gain energy. Collisions between the molecules and atoms take place, and they start moving faster. Then what happens? Therefore, the temperature rises. there will be an increase in internal energy of that substance. So simply speaking, when we are going to heat up a substance, its internal energy increases, right? What happens when we are going to heat up a system? Its internal energy rises, right? Is this clear? आप जब
Yes.
किसी
Yes.
सिस्टम को हीट अप करते हैं तो एक्चुअली as I told you that heat supplied, so delta q is supplied, so it will cause an increase in temperature. So let's start the topic properly. When you provide heat to a system, what are the consequences of the heat? When heat is when heat is supplied to a system, yes मेरा बाप बताओ, जब आप किसी बॉडी को हीट अप करते हैं तो उससे क्या consequences आते हैं?
किसी body को? What do you mean body?
किसी बॉडी को, yes, body, system mean body. So what happens to that body, or what can happen to that body?
Sir, I don't understand the word system here.
No, system mean, let's say I have some ice, I have some anything, what I'm going to heat up.
Oh, well, then its particles will gain kinetic energy and they will start moving faster.
Okay, good. So if we don't look into, or if we don't have any insight of that, apparently what would happen? Yes, yeah, I'm asking to you. Yeah, you are made up, you are right. Microscopically,
Yes.
the molecules would have increased energy. So yeah, what would happen apparently?
When they decrease energy,
Okay,
so less
do you
less
believe that
temperature.
it's do you believe that its temperature would increase?
If it has less energy, no, temperature will decrease.
No, when we supply heat,
Then temperature will
when we heat
increase.
up, for example, when you come out of the shower, you want to sit in front of heater, you are taking heat is supplied to you, so what do you want? Why you are sitting in front of heater? That the temperature of the body should be maintained, or temperature of the body should be raised, is it?
Yeah.
So ice, or when we heat the water, what happens? Let's
It
say मीरब यहाँ से शुरू करते हैं. We are heating water, so what happens to the water when it is heated up?
it
Sir, its
gains
temperature
energy.
increases.
Yeah, its temperature rises. Second thing, if you will continue heating, what will happen?
It will boil.
It's, yes, its state will change, of course. So third thing, which you really observe, its volume increases. Got it? Isn't it the apparent change you observe in your daily life when you heat up a system? ऐसे ही होता है ना
Yes, sir.
कि when we are going to heat up a system, its temperature may be increased, its state may be increased, or its volume may be increased. So let's talk about heat capacity in a proper way. Heat capacity is the heat, amount of heat required to raise the temperature of, this is basically, this topic is heat capacity, right? So you can note it down, or simply you can, I will send you these notes, no need to write it down as it is. So the amount of, this is definition, आपसे ये पूछा जाता है, it can be asked to you. Heat capacity, it is amount of thermal energy required to raise the temperature of a body by 1 degree centigrade, right? For example, you had 5 kg of this block, whatever its mass is, its initial temperature theta 1 or T1 was 20 degrees centigrade, and you heated it up, right? What did you do? You heated it up, and now the new temperature is 21 degrees centigrade. So whatever the energy you supplied from here, that is its heat capacity. Got it?
Yes.
So first you have to remember this definition, and secondly its equation. The equation is, this is capital C. There is a difference between small c and capital C. So capital C is heat capacity, not specific heat capacity. Heat heat capacity mean heat required to change, or heat require amount of thermal energy required to change the temperature of any mass. Any body means any mass, no bound of mass at all. तो आप किसी भी mass का temperature change कर सकते हो. So it is actually equals to, capital C is equals to Q divided by delta T or delta theta, right? So both equations are correct. So its unit is joule per degree centigrade. So remember this thing, there is M missing in this one, right? इसमें आपका M नहीं है ना? M is missing from here. So mass, it is independent of mass. Remember this thing. It is independent of mass. Or you can simply say, okay, let me make it easy for you. It is not for 1 kg, right? It is not for 1 kg. It is for any mass. It is for any amount of mass. For example, you have a 5 kg block or 100 kg block, it does not matter. It is for any amount of mass. But when we talk about specific heat capacity, okay, here are so many problems to be solved. I believe that they would be time taking, but I will just go few of them. In an experiment, 100 gram of the water requires 12600 joules of the heat to raise its temperature from 630 to 60 degrees centigrade. Find the heat capacity of 100 gram of the water. Find the heat capacity of 1000 gram of the water. So as I told you, it is not for 1 kg. So which equation will you use? Q equals to C delta theta, or Q is equal to C delta T. So what is C? This is your, uh, sorry, C is required. So I can say C is equals to Q divided by delta theta or delta T. So Q is how much? 12600. 12600 is the heat required, heat given to that. And what is change in temperature? From 60 to 30 to 60 minus 30. So what will you get? Do you have a calculator?
Say 420.
Yes, it is 420. Got it? Joule per degree centigrade. Right? The same will go for 1000, because I told you that whatever the mass is, we will not use mass formula over there. So it will be simply used as amount of heat supplied divided by change in temperature. Right? So these are some examples. You can take a screenshot of this. These all are
The same.
actually,
Say
yes,
we will not use
mass.
mass in any of these.
And none of I mean, in this first part you will not use. Then in the second one, find heat needed to raise 100 gram of
Wait,
water
sir. Then the answer
from,
for both these parts will be same.
yes. Problem is that whenever we are having this amount of mass, this specific heat, sorry, this heat capacity, this heat capacity is basically that amount of heat which is required to change the temperature of that specific amount, whatever its mass is, right? So its specific heat capacity is the same as this one. Sorry, its heat capacity is the same as that one. So here we are not basically using any mass, so that these kind of informations are just trapped. So check this one. Do we have any mass in this formula? No, right? So I cannot use mass. I will use mass in that equation in which I use Q is equals to MC delta theta or delta T, right? So there, this C is small c. So I will come across that point right in my next slide. This is that specific heat capacity. This is that specific heat capacity. Okay? So you
Sir, I
people,
have a confusion.
yeah,
So where do you know that you have to use which formula? Like formula for heat capacity or specific heat capacity?
huh. It is simply heat capacity, right? It is heat capacity. You will be asked to calculate specific heat capacity. The word specific will be used.
Oh, okay, sir.
Okay. Now check this one. Specific heat capacity is basically the amount of heat required. You have to remember this. The specific heat capacity is small c of the material defined as. You have to memorize this one by all means. Amount of thermal energy required to raise the temperature of a unit mass. There it was not mentioned. I told you that mass will not be 1 kg. Okay, by 1 degree centigrade, right? So this is that equation what I have initially stated. Q is equals to mc delta theta, or Q is equals to mc delta t. So from here, C is equals to what? Q divided by m delta theta. Okay, so this equation consists of mass. So if I say, or if I link this one, मुझे एक बात बताइए, check this one out. In I had capital C is equals to Q divided by delta theta. This is capital C, and I have small c is equals to Q divided by m delta theta. So what is the difference between these two? Yes, yeah, yeah. Isn't it this value of capital C?
Yeah.
So I
Yes.
can say small c is capital C divided by m. So that is specific heat capacity is equals to heat capacity divided by mass. So if you have heat capacity of a substance and you have mass, you people can calculate specific heat capacity, or you can say heat capacity is equals to mass times specific heat capacity. So these are two equations, or these are two relations you have to remember, that what is relation between heat capacity and specific heat capacity. Mass is multiplied by specific heat capacity to calculate heat capacity, right? Is it clear?
Yes.
Okay, so every material has a different specific heat capacity. So I told you that specific heat capacity matlab the heat required to change the temperature of 1 kg of that substance, right? 1 kg of that substance. अब देखो, एल्यूमिनियम है, एल्यूमिनियम के लिए it is 900 joule per kg per centigrade. It means if I have 1 kg aluminium, I want to change its temperature by 1 degree centigrade. I need how much heat? 900 joules, right? If I have 1 kg of brass and I want to change its temperature, so I need 330, and so on. For ice, I need 2100 joule of energy. For seawater, I need 3900 of energy, joule of energy, and for normal ordinary water, we need 4200 joule of energy, which is very big amount. So this means that to increase the temperature of 1 kg water by 1 degree centigrade, by 1 degree centigrade, how much heat I required? We need 4200 joules of thermal energy. Are you getting this thing? Okay, so for 1 kg, I need 4200 joules. For 2 kg, how much it will be? For 3 kg, 3 times 4200, and so on. So आप करते जाओ, 4200, 3 times 4200, and so on. So if I will increase the amount of mass, what will happen? The heat would be increased. Are you getting it? More and more heat is required for me, but specific heat capacity is not changed. Specific heat capacity is same. Specific heat capacity is that heat which is required for 1 kg. मुझे आप ये बताइए, is it, isn't it like, what is the price of 1 liter petrol? Yes, yeah, yeah. Let's say it is 280. So just let's round it off that it is 300. Okay, it is 300. So if I am purchasing 50-liter petrol, right?
Okay.
For this is for 1 liter, right? For 1 liter petrol, I have to pay RS 300. But if I need 50-liter petrol, what I have to do, I have to pay 50 times 300. Meera,
Yes.
are you getting this point? And if I
Yes,
need
sir.
100 liter, I have to pay 100 times 300 RS. Is it? ऐसे है ना?
Yes.
So is this price changed? You are taking 100-liter petrol, right? How much you are taking? You are taking 100-liter petrol. So is that specific price changed?
No,
Naina?
sir.
No, it is 300. Similarly, you are boiling, sorry, you are heating 1 ton of water, or you are heating 1 kg of the water. Its specific heat capacity will not change. Is it clear to all of you?
Yes, sir.
Okay. Now, usually we use electrical energy, heater, and all that stuff. So we have to recall all these equations where PT is equals to MC delta theta, or you can simply say Q. I will write all these equations in a row over here. First, Q is equals to MC delta theta. Second one is PT is equals to MC delta theta. Then VIT is equals to MC delta theta. So these are three equations which are commonly used for the calculations. Here, what is basically Q? Q is energy, thermal energy, right? Thermal energy. So I can say that when I use heater, electric heater, so P into T is basically thermal energy produced by a heater, isn't it? Thermal energy
Yes, yes.
of heater, right? And do you know what is P in your current electricity? P is equals to V times I, is it? And now it will give you VIT collectively. This is thermal energy of a heater. Okay. So whenever you are having a heater with power rating, this equation is used for a heater when power rating is given to you. This is when direct energy is given to you. This is when voltage and current is given to you. Okay.
Yes, sir.
Yes.
Is it clear to you? This second one, when power of the heater is given to you. Third one, when potential difference and current is given to you. Now, let's have some calculations. A domestic hot water tank contains 200 kg of water at 20 degrees centigrade. How much energy must be supplied to heat that water to 70 degrees centigrade? Yeah. What do you need over here? The specific heat capacity of the water is 4200 joules per kg per centigrade.
Sir, MC delta T wala formula will use.
Yes. We will use Q is equals to MC delta T or delta theta. Yes. So Q is required. What is mass? Yeah, yeah. 200. What is C? 4200. And what is change in temperature? Temperature changes from 20 to 70.
Yeah,
So it is
50.
50. So can you please calculate this one for me?
Yes, sir. So 42,000.
42
Thousand.
joules, which is 4.2 into 10 raised power 1, 2, 3, 4, 5, 6, 7, 8. this much joule energy is there. Or you can simply say it is 42 megajoule. 42 megajoule. Mega कितना होता है मेरा?
8.
10 की पावर 6 होता है.
And I had one.
हाँ, 10 की पावर 6. ठीक है, यही है. What is mega? 10 power 6.
Sir,
ठीक है.
personal 10 की
Okay,
power
now
8 है.
ना 10 की पावर तो 8 है, but I have written this in this way: 420000000. So I have shifted decimal 1 decimal 2 3 4 5 6. So it would become 42 into 10 power 6. So 10 power 6 is your mega. So I have written 2 megajoule. Is it clear?
Yes, sir.
Okay.
और सर इसमें वो यूनिट इसका वो नहीं लगेगा जाउल्स फिर केजी माइनस
ना it is नहीं 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 नहीं, हमें चाहिए एनर्जी. हाउ मच एनर्जी इज रिक्वायर्ड. सो एनर्जी का यूनिट तो जॉल होता है. राइट.
यस ठीक है सर गॉट
राइट. ये आपको भी इशू. आप पूछना आपका राइट है. डोंट वरी, यू कैन आस्क एनी क्वेश्चन. यस. या इज दिस क्लियर टू यू एज वेल?
Yes.
या.
Yeah.
यस श्योर. ओके. Part 2. A copper block of weight 2 kg, I mean mass 2 kg, is dropped from a height of 20 meter. Okay, leave this right now because it is in interconversion of potential and thermal energy. Do you have the idea of potential energy? Na mgh हो जाएगा. Yeah, a copper block of 2 kg is dropped from a height of 20 meter. What is the rise in the temperature of the block after it hits the floor? The specific uh, heat capacity of the copper is 400 joules per kg per degree centigrade. So you know how to solve this question. A copper block is dropped from a height. So here it has all of its energy as mgh. So when it is being dropped, all of the mgh is converted into its thermal energy. All of the energy is converted into thermal energy. ऐसे ही है ना? So its mgh is, you can say logically that loss in mgh is equals to gain in thermal energy. Okay, thermal energy. So generally when we drop the things, they are heated up. So it is mgh is equals to mc delta t or mc delta theta. Okay, so m and m would be cancelled out. No need of mass. That's why mass was not basically very important over here. So it is cancelled out. So g is your 9.8, height was 20 meter, and c is 400, and you can calculate delta t from here. Just switch the values. So delta t would be equals to 9.8 divided by 20. So what will be answer? Yes.
सर 0.49
Yes, 0.49 degrees centigrade will be change in temperature. Is this clear to both of you?
तो सर इसमें we
Yes.
just have to like equal them ना
Yeah,
potential loss
actually,
and
one
energy.
form of energy is lost and the other form of energy is gain. So I can say loss in potential energy appeared as gain in thermal energy. So this happened
Okay
in this way.
yeah
Now I'm using this. I'm going to solve this question number 6. A 700 watt. No. A 700-watt electric heater is used to heat 2 kg of water for 10 minutes. Calculate the temperature rise of the water where its thermal heat capacity or specific heat capacity is how much? 4200 joules per kg. Okay, I have free space over here. So unfortunately, I did not place some space to solve this question. So I have to use this one. So this is question number 6 solution. Okay, what is this 700 watt? Electrically, isn't it power?
yes sir
Okay. And what else is given to me?
Mass.
Good. And what is this one?
Time.
Okay. And what is
And
this one?
specific heat capacity.
Yes. So yeah, yeah. Can you please tell me which equation will be used? I have stated two equations for you. I can state it back. Q is equals to MC delta theta or MC delta T. PT is equals to MC delta T, and VIT equals MC delta T. So which equation will be used? Either one, two, or three.
Um, Wait a minute, please. PT.
Which one? Three?
Wait.
Okay, no problem. Meerab will tell me. Yes, Meerab?
Sir, the second one.
Second one. Very good. This time Meerab won the game. So P, listen, P is given to me. I mean, I have P, I have T. I will use this PT equals to MC delta T. So what is P actually? P is, I'm going to write this back over here. PT is equals to MC delta T or delta theta. So P is 700 watt heater is available to you. Yes. And time is 10 minutes. So I have to convert those 10 minutes into seconds. So 10 minutes consist how many seconds?
600.
Okay, very good. So I have to multiply with what, 60. And mass is in kgs. So I have no need to convert. And I have to find out that C is 4200. And I have to find out change in temperature, this one. So yes, can you please calculate for me? And, yeah, yeah. Don't you have a calculator today?
Yeah, I have. I'm calculating right now.
Sir, 420,000 equal to 8,400.
Yeah,
Wait,
T
wait, wait,
is
wait.
850. Delta T is 50.
Total is 850.
Yeah, total delta T is 50.
Okay, 8. Nah, 850 or only 50?
50.
50. Okay, 50 degrees centigrade. Okay, Meera, please counter check this one. When you are going to find delta T, you have to divide this number 8400 on the other side. So just go through whether you are getting this number or not.
Yes, sir, the answer is correct.
Hmm, very good. Okay, is it fine? Now, let's say this last question, question number 10. A 1000 watt heater is supplying an energy. Let me check whether voltage वाला question है मेरे पास या नहीं. नहीं. Okay. A 1000 watt energy is supplied for 100 seconds. A 2 kg metal containing 1 kg of water and temperature rise by 20 degrees centigrade. Calculate the specific heat capacity of the metal. Hmm. This question is linked with the previous one, question number 6. You know, what is this heater doing actually? Heat supplied by the heater, supplied by heater is equal to heat absorbed by container plus water. Is it? Because both of the things are being heated now. So its heat is generated as PT because it is power rated heater and it is working for time. Heat absorbed by the container is MC delta T of that container plus MC delta T of water. Okay, are you getting it?
No, sir, I don't understand this.
Listen, आप क्या कर रही हो? You are using heater to heat up water in a container. So definitely some of the heat would be absorbed by container as well, ना? यानी वो जो कंटेनर है हमारे पास, बॉटल है या वट एवर वी आर हैविंग इन विच वाटर इज इनक्लोज्ड, some of the heat is being absorbed by that one or not?
Yeah.
Yes. So the power generated from the heater is absorbed by two substances, right?
Yes.
Good, got it. अब देखो, mass of the container is 2 kg, its C is unknown, and change in temperature is how much? 20 degrees centigrade. Yes, so its temperature is raised by 20 degrees centigrade, plus mass of water is 1 kg, its specific heat capacity is 400 2400, and its temperature is by 20 degrees centigrade. So I would use all these values in this blank space. So PT, what was the power of the heater? It was 1000 watt heater. How much time it operated? How much time? 100 second. Okay, 100 second था ना? It was 1000 watt heater and it was working for 100 seconds. So PT is P into T, 100 हो गया, is equals to, what is the mass of container? 2 kg. C of the container is unknown. Temperature change is 20. Plus mass of the water is 1 kg. C of the water is 4200 and temperature change is 20. So it would be 100,000. Is it? It is 100,000 on left side. It is your 40C plus it would be कितना हो जाएगा ये? 84000. Now when you are going to solve this, 40C will be equals to 100,000 minus 84,000. So can you please calculate this for me?
Sir, 60.
40C is equals
16.
to 40C divided by, sorry, 40C is equals to 16,000.
Yes.
So C will be equals to 16,000 divided by 40. So it would become 400. तो आपके पास क्या आया C का वैल्यू? It is 400 joule per kg per centigrade. So that container is having this heat capacity. Okay?
Sir, एक मिनट क्वेश्चन दिखाएगा.
Yes. This is that question. Question number 8.
Sir, can you share these questions? Can you share these questions after the class?
Yes, I'm going to save this and I will send you right. Solved one. ठीक है ना?
जी sir.
Yes. So we just did this specific heat capacity topic today. Inshallah, in next class we will discuss about latent heat, and then this chapter would be finished. Okay?
Yes sir. सर एक मिनट, वो जो आपने 3 फॉर्मूलाज लिखे थे MC डेल्टा T वाले, मुझे एक मिनट वो दिखाएगा.
Okay, बस मुझे सेव कर लेना दो बेटा. Yes.
सर ये VIT वाला क्या है?
VIT वाला मुझे बेसिकली यहाँ से कोई क्वेश्चन नहीं नजर आ रहा था जिसमें मैं ये VIT यूज करूं. When voltages will be given to you, none of the question is containing that one. ठीक है?
बस ये मुझे सर
Maybe
ये
some,
और सर PT
हाँ,
वाला वो होता है जिसमें एनर्जी दी होती है.
जिसमें पावर दी होती है. When
Power.
power is given to you, time is given to you, then you will use PT is equals to MC delta zeta. When voltages are given to you, current is given to you, and time is given to you, then you will use VIT is equals to MC delta zeta. ठीक है?
ठीक होगा सर.
ठीक हो गया. मैं बस इसको सेव कर लेता हूँ आप लोगों के लिए. It is almost saved. So we are going to stop it over here. Next इंशाल्लाह थर्मल कैपेसिटी करेंगे. आज थोड़ा सा मैंने स्लो इसलिए करवाया कि हम लोग Actually, we had to complete this